What are quadratic equations and how are they illustrated? In this topic, we are going to illustrate quadratic equations. We are going to start this lesson by reviewing your skills and knowledge on performing different mathematical concepts previously studied in your grade 8. Number 1. Product of monomial and binomial. So we have 2s times the quantity of s minus 4. In multiplying this, we have to distribute the monomial to each term in the binomial, resulting to 2s times s minus 2s times 4. And as simplified, it will become 2s squared minus 8s. Number 2. Product of two binomials. The quantity of x plus 9 times the quantity of x minus 2. Multiplying two binomials, we have to distribute the first term in the first binomial to the terms in the second binomial, and then multiplying the second term in the first binomial to the terms in the second binomial. We can also utilize FOIL method. So we are going to start with the first terms, x times x, multiplying outer terms, x times negative 2, then multiplying inner terms, 9 times x, and then multiplying last terms, 9 times negative 2, resulting into x squared minus 2x plus 9x minus 18. Then simplifying further, we will be having x squared plus 7x minus 18. Number 3. Square of binomial. 2r minus 5 quantity squared. Squaring binomial. In squaring a binomial, we have to follow this format. We have x squared plus or minus 2xy plus y squared. So squaring the first term minus multiplying the first term and the second term times 2, and then squaring the last term, resulting into 4r squared minus 20r plus 25. Number 4. Product of sum and difference of two terms. 2h plus 7 times the quantity of 2h minus 7. The product of sum and difference of two terms. In multiplying this, you just have to square the first term minus square of the last term. So squaring 2h minus the square of 7, resulting into 4h squared minus 49. As we answer all the numbers in this activity, we have noticed that all of the answers are all polynomials, meaning that the exponent on each literal coefficient or the variable are whole numbers. And we can also observe that on each number, the highest exponent of each variable is 2. On this table, we are given different kinds of equations. You can notice here that the equations in blue shade are the equations in linear equations. Linear equations are described as first-degree equations whose highest exponent is 1. We also have here equations that are not linear. They are different from linear equations because this time, the highest degree on those equations or equations in the yellow shade is not 1, but 2. And these equations are examples of quadratic equations or second-degree equations. Real step quadratic equations. On this activity, we are going to analyze the given problem and try to answer it. Mrs. Jacinto asked a carpenter to construct a rectangular bulletin board for her classroom. She told the carpenter that the board's area must be 18 square feet. To help us answer the given problem, let's have first its diagram. So we have here a rectangular board which is 18 square feet. And let us say, for example, that there are 3 students who suggested the following dimensions. First, 1 foot by 18 feet. 2 feet by 9 feet, and the third student says 3 feet by 6 feet. You can see here that all of these are possible dimensions of the said bulletin board, because 1 times 18 is equal to 18, 2 times 9 is equal to 18, 3 times 6 is also equal to 18. But what if there's a student that says the length is 7 feet longer than its width? So how are we going to answer this one? If we are given this kind of problem, therefore we must transform this into, or translate this into, mathematical symbols. For example, when we say that the length is 7 feet longer than its width, therefore we represent width as W. And the representation of the length will be W plus 7, because it is said here that the length is 7 feet longer than the width. So that means W plus 7. And after that, remember that the area of the rectangle is length times width. So therefore, we just have to multiply W and W plus 7. And remember, we are already given the area, which is 18 feet square. So therefore, we come up with this equation. W times W plus 7 is equal to 18. And then distributing W to each term in the binomial, therefore we have W squared plus 7W. And then we just have to perform subtraction property of equality or addition property of equality to both sides. We have to add negative 18 to both sides of the equation, resulting into W squared plus 7W minus 18 is equal to 0. We are actually solving this quadratic equation. So to solve this one, we have to think of factors of 18 that when added, the answer is 7. Therefore, we come up with this one. W plus 9 times the quantity of W minus 2 is equal to 0. You can see here that 9 times negative 2 gives us negative 18, but when added, 9 plus negative 2 gives us positive 7. So therefore, the values of W are negative 9 or positive 2. Now, if we are considering dimensions of the rectangle, we cannot have negative 9 because that is extraneous one. We do not have length that is negative. So therefore, we have W is equal to 2, or the width is equal to 2. And then going back with the problem or the representation, that its length is 7 feet longer than its width. So therefore, we add 7 to 2. Therefore, we have the length is equal to 9, and this will be the dimensions that we need based on the given problem. After doing the 3 activities that we now have the definition of quadratic equations. A quadratic equation in one variable is a mathematical sentence of degree 2 that can be written in the following standard form. Ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and a should not be equal to 0. This form of quadratic equation is said to be in standard form. Quadratic equations are also called second-degree equations, since the highest power of any term in the equation is 2. Another, in the equation ax squared plus bx plus c is equal to 0, ax squared is the quadratic term, bx is the linear term, and c is the constant term. Example number 1. 2x squared plus 5x minus 3 is equal to 0. The given equation here is already written in the standard form. So we just have to identify its a, b, and c. So a is equal to 2, b is equal to 5, and c is equal to negative 3. Example number 2. 3x times the quantity of x minus 2 is equal to 10. We can see in this example that there is no highest exponent, which is 2. But we can transform this into quadratic equation. Multiplying 3x to the binomial x minus 2 gives us the following. And then we just have to transpose 10 to the other side of the equation. So all of the terms will be written on left hand side of the equation. This time it is now written in the standard form. We have to identify a, b, and c, which are 3, negative 6, and negative 10 respectively. And example number 3, the quantity of 2x plus 5 times the quantity of x minus 1 is equal to negative 6. This is another example that is not yet written in the standard form, or we can also identify this one as quadratic equation if we have to simplify this. So performing the FOIL method, we have 2x squared minus 2x plus 5x minus 5 is equal to negative 6. Simplifying further, we have 2x squared plus 3x plus 1 is equal to 0. And then identifying its a, b, and c are 2, 3, and 1 respectively. Example number 4. 16x squared minus 9 is equal to 0. On this example, we can see that there are only two terms on the left-hand side of the equation. And some of you might think that this is not an example of quadratic equation. But this is actually a quadratic equation since we still have a, which is 16, but b, x, or the linear term is missing. So therefore, we have b is equal to 0. And the constant term c is negative 9. So you can still consider this one as quadratic equation. And I am leaving this task for you to answer, and then we are going to discuss this in our lesson. Number 1, 3x times the quantity of x minus 2 is equal to negative 7. And number 2, 1/2 times the quantity of h minus 6 is equal to 0. So you just have to tell whether the given equations are quadratic or not, and then explain your answer. Does it illustrate me? The length of the swimming pool is 8 meters longer than its width, and the area is 105 square meters. Number 2, Edna paid at least 1,200 for a pair of pants and a blouse. The cost of the pair of the pants is 600 more than the cost of the blouse. On these examples, you have to determine whether the following situations illustrate quadratic equations or not. Set me to your standard. Number 1, 2x times the quantity of x minus 3 is equal to 15. Number 2, the square of x plus 2 is equal to 3 times the quantity of x plus 2. On these examples, you have to write them into standard form.